So the chapter 3 test is coming. This looks very much like it, little more at least condensed as the way it's written, but this will help you review for the test. So this is the information that you want to know for the test. As soon as you finish this, just turn it right in so that you don't lose any points on it. And let's look at our first sets of problems here. It says, select all the following which represent y as a function. So a function, remember, will pass the vertical line test. So in this particular case, this passes the vertical line test. So yes, that's a function. Our next one here, we'll do these top three. Yes, that's a function. The problem with this one here is this section right here, there are multiple ones that line up vertically, so that's not a function. This one's okay, that's a yes. And this one's okay, that's a yes. So every one of those would be considered a function, except the third one down. We have some areas of the graph that line up vertically, so it fails the vertical line test. The next thing that I want to talk about is one-to-one. A one-to-one function has to pass the vertical and horizontal line test. Okay, so the ones that are not functions we disregard. So that one can't be one-to-one if it's not even a function. Okay, it can't be one-to-one if it's not even a function. But we're just going to look at the ones that we have listed as a function as to whether or not they are one-to-one. So if we look here, a horizontal line can hit that function in many different spots. So this is not one-to-one. Same thing here. Horizontal line can hit it many places. It's not one-to-one. The third one we don't even have to worry about because, it's not even a function to begin with. So we're going to move on to the fourth one, that horizontal line. Of course, that isn't one-to-one. It fails the horizontal line test because a horizontal line can hit it a million, trillion, bazillion times. So it's not one-to-one. The only one of our functions that passes the horizontal line test is our last one. This is the one that is one-to-one. Okay, so I will give you a mixture of functions. You will tell me whether or not they are functions, and from those that are functions, I will say, is this one-to-one or not? Okay, so I will provide some graphs for you on the test. Now let's, I didn't see there was one more. That is not a function. I'm sorry, these are so spread out. It was from a PDF that's the way it popped out. So that's the way I kept it. Let's look at question 2. Now to see whether or not something is a function or represents a one-to-one function from a table, it's kind of the same idea. If the x's are all unique, then it's a function. So if the x's repeat, it's not. So let's do that first. So these x's are all different, so that's a function. We don't even have to look at the y's. The y's are allowed to repeat for it to be a function. X's are all different, it's a function. But in the third one, the x's have a repeat, not a function. So that one is out for being a function, so it can't be one-to-one function. Now let's go back to our tables and determine if any of these are one-to-one. One-to-one means that our x's and y's are paired up exactly once in both directions. So if you'll notice here, our y's are each uniquely distributed, and so that would be one-to-one. But because of the 7's here, it is not one-to-one. Okay, so you can tell that from a graph or a table, just looking to see, do we have repeats in the x's? That means they would line up vertically. They would not be a function. And then once they're functions, if you test it horizontally, that means the y's would repeat. It can only be one-to-one if there are no repeats. So are we good with question number 2? Okay, let's look at question 3. It says the plot below represents the function f of x. Evaluate f of 4 and solve f of x equals 4. So the first one, in this particular case, f of 4 means what is the height when x equals 4. That's really what that says. F of 4 means the function's height at an x value of 4. So if you go to an x value of 4 and you go up and look on the graph, since that's the point 4, 2, the answer is 2. When x is 4, my height is at 2. Now, for part B, I guess, the solve f of x equals 4, this is saying when I know the height is 4, what x's will make that happen? So let me repeat them. This one is saying my f of x, or my height, is 4. So when the height is 4, what x's will make that happen? There are times where you have more than one answer. So what I like to think about is if my height is up here at 4, just look to see where my graph crosses that line. So this is the place, because when x equals -4, I am at a height of 4. So x would equal -4. So that one just is asking a slightly different version of the question. So if they say, what is f of 4? That's the x that's 4. If they say f of x equals 4, that's the y value, or the height, that is 4. Different things. Everyone okay with question 3? Let's look at question 4. On the test, I will be asking you the same exact things I asked you on the parent function quiz for 3.1. So let me remind you what those things are. So the first one, it says match each function name with its equation. So y equals x is our linear function, and you will have to graph that. And remember to graph that, that's that perfectly straight line that goes through the origin and has a slope of 1. The second one, y equals the square root of x, is our square root function. To graph that, remember, you can use good points like 0, 0, 1, 1, 4, 2. And so it's like a half of a parabola that's laying on its right side. Okay. See, if you think about, this would be the full parabola, but it's only that top positive half. Let's look at the third one. That is our cube root function, or e. Now it has that same feature like a square root. It has that little swoosh over to the right side, but it also, you can plug negatives into that, so that's why you have a little swoosh over to the left. So it's very much like a square root, except I am allowed to plug negatives into that. Let's move on to the fourth one. Y equals x squared is a quadratic. You can call it a parabola if you would like as well. Quadratic or parabola is perfectly fine by me. To graph that one, remember 0, 0, 1, 1, -1, 1, would give you a parabola. So on the quiz, or on the test, I'm sorry, please graph it to that 3 points of accuracy. Next one is the square root. I'm sorry, it is not. It is the absolute value function. Some of you are trying to make it curved like a parabola. It is not. It is the linear function made perfectly positive. So it goes perfectly straight in the first quadrant, slope 1, and this half has a slope of -1. It is a portion of a linear function, a piecewise function representing our linear function. So make it straight. It should not have a curve to it. Our next one is our y equals x cubed, which is our cubic function. It is not going to look like e. It is going to look like more of a half a parabola up, but a little steeper, and then the negative side goes down. These are related. Look at them. They each have a positive and negative piece, but this one is more parabolic, up and down. This one looks more like a square root. It's closer to the x-axis because the square root of 4 is 2, but 2 to the 4th is a lot higher, or the square root, or the square of 2 is 4, a lot higher. The only other functions are these two, and then we did have another parent. I'll talk about that in a second. We had 9 of them. The next one, this is our reciprocal function. Remember, for our reciprocal function, we should have a dashed line on the x and y axis. You can't see that really well. Let's see. Let's find another color. So you would have a dashed line on your x and y axis. However you make that. And then we have that 1, 1 swoop. And we have a -1, -1 swoop. So that is what a reciprocal function looks like. Finally, f is our reciprocal squared. Still has a dashed line down the x and y axis, but this time our positive swoop doesn't change, but when we square a negative, what happens to it? It becomes positive. So that's why this swoop is right here. It just takes that negative swoop and flips it. Okay. The last function is our constant. Let's call that g. You're going to pick any value you want and make a horizontal line through that value. So the only one from our parent list we haven't added, you can add on there, is the constant function. So on the second part of the test, you will be given, just like the 3-1 parent function quiz, I will give you the 9 blank graphs. And the name of the graph, you tell me the equation and the graph, okay? And at least go to that, like 3 points of accuracy. So those are the 9 parent functions. This was from lesson 3.1 if you want to review that, okay? So that's the 3-1 parent functions will be on the test. Let's take a look at question number 5. Question number 5 says to evaluate f of x when f is equal to -4. Now remember, that is your x value. So f of -4, wherever the x was originally sitting, so in this location here and here, put in parentheses -4. Now parentheses, especially for a negative value or an expression, is really going to be helpful to you because you have to follow order of operations. So when we square that negative, that's going to be 9 times 16 minus 8 plus 5. 9 times 16 is 144. So that's going to be 144 minus 8 plus 5, which is 141. So just make sure that you're following order of operations, parentheses, parentheses, parentheses. And that is the best way to do any type of function input. Remember, you're just inputting -4. And then getting out a value, okay? Are we good with question 5? Okay, skip question 6. Let's move on to question 7. Now it says, what is the range? We are going to do domain and range. Remember, domain are the set of x's, and think about going from left to right. So the leftmost x value I can almost get to is -6. I can use all of these, and then I can stand at 2. Now remember, we put a bracket on anything we're allowed to stand on, and we put an open circle parenthesis on anything we cannot. So our domain, I can almost get to -6, so I'll put that in a parenthesis, but I'm going to put 2 in a bracket. Now that's your domain, all the x's you use from left to right. The range, remember, are the y's, and we think of that from the bottom of the graph to the top of the graph. Bottom to top, lowest to highest. It's always lowest to highest. The range value, even though there's an open circle here, there is a spot that I can stand at 2. So I can stand at 2, 2.5, 2.8, 3, 3.5, 3.6, 3.7. There is a spot, because that's a nice smooth curve, that it appears as if I can stand at a height of 4. So my heights for my range, I can stand at 2. It doesn't matter if there's an open circle as long as there's another place where that works. And then I am going up to 4. Any questions about domain or range? Okay, see where it says use interval notation. That is the kind of notation I want to see for the answer for domain and range. Okay. Remember, if a graph keeps going, like if say we have a parabola, let's say that parabola is at a vertex. Let's go of 2, 1. The domain of that is all real numbers. The range of that, the lowest is 1, the highest is infinity. So, be mindful, if it is a nice function that has those arrows on it, like if that parabola keeps widening, it will eventually cover all x's. And then you can also think, I can plug in whatever x I want to a polynomial. So the domain is all real numbers. So you can write that with the little r symbol, or you can write that as -infinity to +infinity. So there is question 7. Okay. For question 8, I did add a little piece to it. Here's the information you want to remember. Let me add one other thing, that a polynomial. There are 3 types of domains I'm going to ask you about. A polynomial, the domain is all real numbers. A square root, the domain can be found by setting the inside greater than or equal to 0. For a fractional function, the domain can be any number except where the bottom equals 0. So these are the facts that you want to have memorized about looking at a functions domain. So our first one says, find the domain of f of x equals the square root of x minus 2. So for the square root of x minus 2, it's a square root. Just remember, take the inside, set it greater than or equal to 0, and solve that inequality. Now, the only thing you have to worry about solving inequalities is if you multiply or divide by a negative, you turn the symbol. We're just adding. We're just adding 2. So it's just x is greater than or equal to 2. Now, that is the answer, but not in interval notation. Let's think on the number line. If I am at 2 and I shade to the right, just make an interval that kind of matches that. So the domain for this first one is anything from 2 to infinity. Now think about the graph of our square root function. That would be a square root function that I picked up and moved to the right. That would have x values from 2, and it would swoop to the right, so it would go to infinity. So the graph can give you that information. The greater than or equal to 0 will give you that information, but you have to know how to find the domain of a square root function, because those are the x values I'm allowed to plug in. Now, for B, for a fractional function, the concern should be what value will make the bottom equal to 0. So just set the bottom equal to 0 and solve it. And then put a slash through it. Those are the values I must skip. That's the only value I have to skip. So on the number line, I'm just skipping 6. But I can shade to the left and the right as far as I want to go. Okay. And so this would be the answer as far as inequality or set notation, but I want interval notation. So the domain for this one, I go up to 6. There's a hole there. I jump across the hole and I can keep going. Do you see? This means we skipped 6. So that notation means I skipped everything, or I skipped 6 and I can use everything else. Now, if there's more than one of them, you skip over whatever one's in number line order. Oh, there's a, I got to 1, I'm skipping it. I got to 4, I'm skipping it. I got to 7, I'm skipping it, okay? And then the last one is the easiest. If it says what is the polynomial, or what is the domain of a polynomial function, there's nothing that messes that up. It's all real numbers from negative infinity to positive infinity. So domain is only what x's can I use, what x's are messed up. Okay, so that's kind of what you think about when you're thinking about domain. What x's work, what x's will not. Okay, that is your main thought process. Any questions about all the domain stuff in question 8? Okay, skipped question 9, skipped question 10. Please jump for me to question 11. This is question 11, and it says here, we're just going to do this first one. It says, what was the average rate of change of the annual sales between 2018 and 2019? Remember, average rate of change is just a slope, which is y2 minus y1 over x2 minus x1. They're just asking the slope between those 2 points. So find the points that they're talking to. Here's an x value of 2018. Here's an x value of 2019. To find the slope between 2 points, you need two points. They've given you the 2 points. 2018, 246, we'll call that x1, y1. And 2019, 241, We'll call that x2, y2. And it's just sloped like any other slope that we've ever done. So it's going to be y2 minus y1 over x2 minus x1. Just plug it in. Now, the difference on the top is -5. The difference on the bottom is 1. So that means that we lose $5 million per year. Okay, so your slope is -5. And in this particular context, there are words. I think the one I gave you is just find the average rate of change. Bam, you're done. Okay, but it is, we have lost $5 million per year. Any questions about question number 11? Okay. Question number 12 says find the absolute maximum and minimum for the given graph. Give your answer as an ordered pair. Well, the absolute max or min of a graph that starts at a spot and ends at a spot without any breaks in the graph will always either happen at an endpoint or at a bump. So let's label the bump because, or at least put the dot on there for now. And what we can find is that this point right here, -2, 0, is our absolute minimum of the graph. And this point here, 4, 0, is, I'm sorry, that's the 0.04. The 0.04 is the absolute maximum. Now for me, just labeling them on the graph is going to get you what I want. They wanted the ordered pair. So the absolute maximum is at 4, the 0.04, and the absolute minimum is 0 at the point -2, 0. And that's all you got to do for that kind of one. Okay, find the points, label them, and if it's for me on my graph is perfectly a great option to do that. Okay, so that's question 12. Let's move on now to question 13. For 13, we are using 8 for all of our inputs. You notice that? We have 8 down the line. So my suggestion to you is let's plug in 8 into both of our functions so we have those values as resources, okay? Now if I plug 8 into my top function, that's going to be 64 minus 88 plus 30, or 6. So I just plugged in, followed order of operations. I plugged 8 in. Now if I plug it into my bottom function, that's just 8 minus 6, or 2. Now I'm going to use that over and over and over and over again. So f plus g of 8, what does that really mean? Well, this really means f of 8 plus g of 8. That just means add those two functions when I plug in 8. Well, if I plug in 8 into f, I already found it, it was 6. Plug 8 into g, I already found it, it was 2. The answer is 8. That's all, okay?
I have a question. So don't you plug it into the one that it's closer to, so you'd always plug it into the g first? So would you put the g first?
Watch the notation. If it has an f plus g of 8, that is not a composition where we work from the inside out. It just means...
Oh, I meant like the minus, like would you work from...
No, same thing. The next one, the second one, that is not a composition. That just means f of 8 minus g of 8. Yeah, so the addition, subtraction, multiplication, and division is just evaluate each one separately and then add them, subtract them, multiply them, or divide them. Yeah. We're going to do one like a composition like you were talking about. Okay. So here, that's just going to be 6 minus 2, or 4. This is going to be f of 8 times g of 8. If it was an expression, if there was maybe signs to it, parentheses are a good idea, but it's just really 6 times 2, or 12. And then the last one means f of 8 divided by g of 8, We've already found those values. We've done the hard work. So that's just 6 divided by 2, or 3. So those ones, don't overthink them. You make them harder than they have to be. They're not. It is just add the function values at 8. Subtract the function values at 8, and so on. It's not until we have that open circle notation that we have to do kind of inside out.
Okay,
so like 14. Yes. Okay, so let's look at how 14 and 15 are using a different notation. They have that open circle. The open circle notation means composition. So we're composing those functions. So that's where we have to start from the inside out. Okay, so let's look at A. So that really means f of g of -3. F of g of -3. So that means if we work from the inside out, we're going to plug -3 into g, which is this function right here. -3 minus 5 is -8. We're going to get that answer of -8. And then that -8 goes into f. Now, be careful when I plug into f, I would definitely want to use parentheses because it's going to be -8 squared minus 2 times -8. -8 squared becomes a positive 64. The -2 and the -8 are sitting next to each other. Two negatives multiply together and give me a positive 16 for a total of 80. Now, B is different. B is different because that means g of f of -3. This time we put the -3 into the f function. So let me do that kind of up here out of the way. So if I plug -3 into my f function, that's -3 squared minus 2 times -3, which is 9 plus 6 or 15. So that's really g of 15. Okay, so we get that 15 value first, and then that 15 goes into g. So that's just going to be 15 minus 5, or 10. See the difference? Watch the notation. Add, subtract, multiply, divide, multiply, those symbols are very simple calculations. The most complicated ones are the compositions. That open circle notation worked from the inside out. So for 15, let's do f of g of x like they've asked. Now, when we do f of g of x, so this notation means we are sticking g of x into f. We're sticking g of x into f. So let's write g of x right there. G of x is this function here, x plus 7. That will be our input. Now, when we input that, that is going to be whatever we input squared plus 1 times the input. So whatever we input squared plus 1 times our input. We have to do x plus 7 times x plus 7. You have to FOIL that. You have to distribute that. Okay? So you're going to get x squared plus 7x gives you 14x plus 49 plus x plus 7. So you get a big long list of things. Now, if there was a number here, distribute it, but I distributed a 1, so that's why these didn't change. So that I FOILed, that just 1 times that. And then combine your like terms for a final answer of x squared plus 15x plus 56. Now, if they asked us to find g of f of x, we'll get a completely different answer. So be careful, start from the inside out. You input the inside thing into the outer thing, inside out. Okay? Everybody good with 14 and 15? Okay. 16 says, if the formula x cubed is changed by adding 5, what effect will it have on the function's values? You can say that it will change the y's by adding 5. So it's going to move the graph up 5 units. So that's what they were looking for there. So remember the rule. If you add on the outside, it moves up. Subtract on the outside, move down. So add on the outside, moves up. Subtract on the outside, move down. Add on the inside, goes left. Subtract on the inside, moves right. Okay. Those are the 4 main ones. Now, obviously, we had some others about compressions and stretches. I am worried about those, but not as much as getting that main fundamental, can I move it left, right, up, and down? And of course, flipping over the x-axis is one that's pretty important. So let's move on to 17. So it says if we want to take the graph of y equals x squared and translate it to the right 9 and down 6. So the right 9, we are going to subtract on the inside. So that's going to be x minus 9 squared. So it's going to be in the square. And this means down 6 is a subtraction on the outside. So we're going to have a minus 6. So our equation would be y equals the quantity of x minus 9 squared minus 6. So look over 3-5 notes, all the rules of your transformations. That would be a good place to look for all of those particular transformations. For question 18, it says, which of the following shows the graph of 5, the quantity of x plus 1 squared minus 2? You should recognize that it's a parabola, which they all are. This parabola's vertex has gone left 1 and down 2. So the vertex is now at the point -1, 2. So that's the first thing you want to find. Oh, down 2, I'm sorry, -2. -1, -2. So this vertex is in the right spot. This one is not. That one is not. That vertex is not in the right spot. 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 So we only really have 2 where the vertex is in the correct -1, -2 location. Okay, so the first thing, always find the vertex. Now, the vertex happens at -1, -2. Let's plug in 0 because it's right to the right of it. And if we know one other point on our parabola, it should tell us what's happening. So if you plug 0 into the original equation, you get 1 squared is 1 times 5 is 5 minus 2 is 3. So just look which parabola, when I plug in 0, do I hit 3? This one, when I plug in 0, I do not hit 3. This one, when I plug in 0, I definitely hit 3. So this is my answer. That is the only one that hits the right vertex. It moved left 1 and down 2. It hits the right kind of skinniness. That 5 pulled it up higher. It was a stretch. And so you'll see instead of going out 1 and up 1, it went out 1 and up 5. So that's kind of how it stretched it upward. Everybody good with question 18? Okay, we're skipping 19. And we are going to now move on to 20. We're almost done. We're getting there. Let's look at 20. It says use the table to fill in the missing values. So it says, what is f of 3? So f of 3, that means x is 3. Just find the point on your table. The answer is 6. Those are always lovely, aren't they? Okay, let's look at the next one. It says if f of x equals 7. Now remember, this was your x. This is your y value. What is your x? So this one, we are looking for a y value of 7. That might have more than one answer if it is a function. So when does the y value equal 7? Well, when x is equal to 1. That's this point right here. Now, the next one, see how it has the inverse on it? So an input into an inverse isn't an x, it's a y. It goes backwards. Remember, we flip-flop the x's and y's? So this input into our inverse is not an x like we expect, it's a y value. So find where does y equal 6? Well, y equals 6 right here. And what is the matching pair that goes with 6? Because if 3, 6 is in our function, the 0.63 is in our inverse. So the answer is 3. The inverse flips the x's and y's. So this input here is a y value. So just find the y value of 6. The answer is 3. It goes backwards. We don't input x's, we input y's. So this one, the output of an inverse function is the x. So this is, where is x equal to 1? It's going the opposite direction. So here, just find where x is equal to 1. The answer is 7. This will be posted. 21, find the inverse. If you want to find the inverse, you're just going to write it in y notation. You're going to flip-flop the x's and the y's. Wherever the new y is sitting, solve for that in your equation. Make it say y equals. Solve for that new y. So I'm going to subtract 9 from both sides to get that y term by itself, and then divide both sides by 9. Now it's the whole thing divided by 9, so don't think you can only just cancel out the 9's there and make it a 1. You can't. Leave it like that. You could possibly put it like that, x over 9 minus 1, but why waste your time? This is just x minus 9 all over 9. So remember, to find an inverse, we're going to flip-flop the x's and y's. Wherever you see the new y, just solve for it using your rules of solving equations, and that is your inverse. Skip 22 and 23. The last thing we're going to do is 24. For 24, we're going to use the graphs to find those composition values. Let's just do this one and this one. Actually, let's do that one. Yeah, that should work. Actually, let's do the bottom one. So skip those. Okay. F of g of 0. We're going to start at g of 0. What is that? Well, when we go on the g function, which is this one, when x is 0, we are at the point height of 4. So that's 4. And then, so f of g of 0 is just f of 4. So now we're going to go over to the f function, and we're going to find 4. And the answer is 0. Okay, so let's do it again. We're going to start at 0 on our g function. We're going to find the height. The height is 4. We're going to input that into our f function. So it's saying if f is 4, what is our height? Our height is 0. Okay. Now let's do this one. You will see we have g of 5. So we're going to use the g function twice. So if I say g of 5, we are starting with g of 5. Start from the inside out. So if I go on to my g function, which is this one, and I find an x value of 5, I'm at the point 5, 3, so that's 3. So that is 3. When I look at 5 on the g function, I am at a height of 3. When I look at 5 on the g function, I am at a height of 3. Everybody see how that works? Okay. Now, I am going to use the g function one more time, but I am going to look at an x value of 3. An x value of 3 on the g function, what's my height? 2. The answer is 2. So the test will be in 2 parts. The first part looks very much like the function stuff, using the functions, graphs, inputting into functions. The second part is more of, can you graph these particular functions and the parent functions? So the second part's graphing and the first part is more using the functions, okay? So please study. We have one more thing. If you could please go into Google Classroom. There is a 3-5 number 2 worksheet, which looks like what you see there. And your homework tonight is to study and do this. Now, what you're going to do is you are going to look, just follow my example. Any place you have a yes, except the last 2 columns, I need a description of what happened. Oh, it moved left, it moved right, it flipped over. Okay, so it's just yes, no, yes, no, yes, no. All the yeses, I want a description, except the last column, like a quadratic, is either both going to go up or both going to go down. A cubic, one side goes up and one side goes down. So that's what I mean there. Are the ends pointing up or pointing down? If you have both, just put yes. But that, I don't need any explanation for the last 2 columns. I just need explanations here. So that's your only homework. Study and say yes, no on this worksheet. Okay, and any yeses get an explanation except the last 2 columns. So that is your homework. Study, study, study. If you haven't turned in this review, please return it in to get yourself some points so you don't forget that. And there you go.